Good afternoon, everyone, and welcome to the AIM Young Professionals Town Hall. I'm Michael Allen, the Business Development Director for AIM. I'm really glad you could join us today. This town hall is designed to be informal and conversational. The goal is to connect early career professionals with some of the people who help shape the AIDC industry and to talk honestly about careers, standards, technology, and where the industry is going. We are especially excited to be joined today by Dr. Clive Hoberger and Sprague Ackley, two individuals whose work has had a lasting impact on barcoding, RFID, and standards development. Before we jump into the discussion, there are a few items I will review. First is AIM's antitrust policy. This is standard practice for all AIM meetings and town halls. The short version of this is that AIM meetings are designed for collaboration, education, and work that benefits the broader industry. That means we do not discuss confidential business information, pricing, unpublished product plans, or anything that could be viewed as anti-competitive. If at any point someone feels the discussion is drifting into that territory, we will simply table the topic and move on. This keeps these conversations open, productive, and safe for everyone involved. Closely related to this is AIM's collaboration and work product policy. AIM committees and groups, including the Young Professionals Group, exist to create non-confidential public domain work that helps move the industry forward. Nothing proprietary should be shared, and anything developed through AIM is intended for the benefit of the broader ecosystem. This is one of the reasons AIM has remained a trusted, neutral forum for standards, education, and advocacy for decades. And a few quick housekeeping items before we jump into the conversation. All participants are muted upon entry. If you would like to ask a question, please use the Q&A feature at the bottom of your screen. I'll either ask those questions on your behalf at the end, or we can unmute you and let you ask directly. This session is being recorded, and we'll make the recording available in the coming days for anyone who could not attend live. So for those who may not know AIM, we are a industry alliance representing organizations that use, implement, resell, or develop technologies around barcoding, RFID, RTLS, and mobile computing. Our role is to enable adoption, growth, and interoperability across these technologies, and we do this through education and insights, advocacy, standards, and community. AIM is intentionally unbiased and global, which allows competitors, partners, and innovators to collaborate in a neutral environment. And one of AIM's biggest strengths is the diversity of its membership, as we are a nonprofit global trade organization that brings together technology providers, end users, integrators, and solution developers. Through AIM, members network with peers, influence the direction of the industry, and participate in committees that tackle real-world challenges. This collaborative model is exactly what allowed technologies like barcodes and RFID to scale globally. That's the same model we are applying to newer areas like AI, automation, and digital identity, which brings us to our Young Professionals Group. The goal of this group is simple, and it's to create a forum where early career professionals can gain knowledge, get honest advice, and access tools that help them grow within the AIDC industry. Today's call and future larger town halls are going to be centered around launching those tools and building a stronger community. This is not just about listening, it's about participation, helping the next generation shape the industry. With that context in place, I'm excited to introduce today's speakers. Dr. Clive Hoberger is a former AIM chairman and a pioneer in AIDC, standards development, and healthcare identification. And Sprague Ackley has also had a long and influential career in this industry with creating innovative patents, helping develop standards, and working on many real-world AIDC deployments. Both of them have not only been built symbologies, they've helped shape the standards and ecosystems that allow technologies to be trusted and adopted globally. And today's conversation is really about learning from their experiences, the successes, the challenges, and the lessons they wish they had known earlier in their careers. So with that, Clive, we can start with you.
Okay. My life before AIM and AIDC has caused, basically the whole industry changed me. Originally, I planned to be a radio astronomer, and I started my career, my education off that way, but I ended up getting a PhD in this new field, computer engineering, at Case Institute of Technology, now Case Western Reserve. And I spent 4 years on the staff of the instrumentation division at Brookhaven National Lab getting into this new field of real-time computer data acquisition in physics and biology. It was amazing what we could do with a PDP-8. My postdoctoral research was at Montreal Neurological Institute, where we developed the first computer-assisted brain surgery for blood vessels using a PDP-12, and it worked great, and we cured 55 patients. Later, I led biomedical engineering, a new science at Abbott Laboratories R&D. Again, we focus on real-time data acquisition and analysis from instrumented test animals. Later, I developed a new technology called fluorescence polarization immunoassay for clinical assays. It's still in use. My career stalled out at Abbott, not due to failure, but due to success. My boss and all above wanted to claim credit for my work. And basically, I was told, we can't promote you. You're too valuable doing what you're doing. And I realized that was not quite the way that I wanted to go. And I was contacted by a headhunter about this a new technology, barcode labeling, and they were searching for a VP of R&D at Weber. And I realized the business model for our barcode labeling was exactly the same thing as for hospital products, single-use disposables used with capital equipment. At Weber, I introduced digital graphics printing on labeling, but I left Weber in 1984 to join a startup company called Data Specialties as VP of Corporate Development. DSI became Zebra Technologies in 1985. In 1985, the major barcode label users were DoD, Kmart, Walmart, and UPS, and the latter three using the 4x6 standard barcode shipping label. There was a major scannability issue with dot matrix printed labels because of the size of the dot relative to the size of the barcode, basically what we call the X dimension. And Kmart introduced fines for shipping labels that they were unable to read. That changed the game dramatically. So at ESI, I spent much of 1985 developing the Zebra 130, a 5-inch 200 DPI thermal transfer printer with a rectangular dot, which was designed for on-demand labeling printing. To support Zebra products, I designed a language called ZPL for label programming in 1985, and all Zebra products, printing products since then have used it. We introduced this at Scantech 1985, and it was an immediate success. And so Zebra basically went after all the Printronics resellers to become their channel partners. My history at Zebra is simple. I joined Zebra in 1985 as a corporate VP when I was $5 million a year, and I retired in 2008 at $1 billion a year. Today, consumers have expectations of color everywhere on electronic displays and billboards, and a desire to make printed packaging more attractive because of widely available color printing. But many barcodes today are displayed and never printed. Good example is theater tickets. New barcode applications, many use 2D error correcting barcodes rather than linear barcodes, especially QR code. And I had the pleasure of heading the standardization effort for QR code at the AIM-TSC. Packaging space is also limited, and through the use of color, UltraCode has 9 times the spatial data density of QR code. But the big thing in developing a color barcode was the question people kept asking, who's going to make a color scanner? One day looking at my iPhone, I realized there was already an excellent one, the smartphone. And smartphones now with apps are frankly the largest selling barcode capable scanner and are starting to displace barcode only scanners, particularly in places like hospitals where everyone's carrying a cell phone anyway. A smartphone-based ultracode has been an AIM symbology standard since 2016. Unlike previous color designs, ultracode is entirely focused on scannability, not only of the symbol structure, but of the color modules. And each color stack of five colors above and below of a black bar is a symbol character. We only use uh, cyan, magenta, yellow, and green in the 5 module stack as data tiles. The next area is something to think about, but as you know, magenta fades to white, which is why reds disappear on printed objects left out in the sun. And we don't use blue and red in ultracode because of the fact magenta fade causes red to fade to yellow and blue to cyan. And so you can't discriminate between the real and faded modules. So we don't use red and blue in ultracode, but we do use green. One of the problems you have with a color barcode is uncontrolled lighting and color inaccuracies. Even some of the best laser printers produce inaccurate greens and inaccurate magentas. And so what we use is an AI application called an adaptive classifier. It knows that in that particular module space, the color has to be cyan, magenta, yellow, green, or unknown. And so it looks at all the colors there and classifies the ones in the color spaces into one of those uh, 5 boxes. UltraCode supports both the 8859 series and UTF-8 as default character encodings. So it is international in its scope, and it's currently in the ISO standardization process to become ISO 25449. ISBT 128 is a standard which was originally developed for blood and now has been expanded in its usage. The first Gulf War showed up the absolute chaos in national blood labeling standards when all these countries contributed blood to the first Gulf War and Operation Desert Storm, but they were all labeled in different ways, and the US Navy had to try and sort them all out. So in 1989, the ISBT, the International Society for Blood Transfusion, the superorganization of national organizations, was asked to develop a global language independent barcode labeling standard for blood. Bruce Ray of Computype and I were asked to co chair the development because we were both barcode experts with blood and medical expertise. And I got appointed as the ISBT 128 standards editor. The standard was issued in 1994 and by 2010 was in use in over 30 countries. In 2012, I developed the first FDA-approved RFID-based blood bank using ISBT 128 data structures at Blood Center, Wisconsin. The key thing happened after 25 years in 2019. The World Health Organization adopted ISBT 128 labeling standards for all medical products of human origin, cells, tissue, breast milk, any product that comes from a human being that can be used in therapy. In 2025, we now have ISBT 128 in use in over 80 countries for blood and many countries now for medical products of human origin. So standards organizations really matter. And they matter because of the fact that organizations like AIM, GS1, and ISO permit you to get a preview of the industry and market future and to participate in the development of that future and grow your own market and technical knowledge. Standards meetings are a great common ground on which to meet your competitors as well. You can look there for market intelligence and to find career opportunities. And the term co-opetition, that is cooperation between competitors, was a key to the explosive growth of the AIDC industry, which is why I know Sprague so well. Let me talk about some career warning signs for you young professionals. And some of the signs are when your bosses make a presentation to the board about all your great work and don't mention your name. And then you're told, we can't promote you. You're too valuable doing what you're doing to them. And when the company requires and pays 100% of your MBA as part of the executive development program, and then the CEO tells you not to expect any career reward for getting it. And also an issue which I think is going to become more important in the future is when you encounter latent or overt racial or religious discrimination. Um, it, and when you're on the board of a family company, I just spent 15 years on one, of a C corporation and find out that the whole business strategy is really running the operation like a bodega, stripping all the cash out through dividend payments, and there's no cash available to grow the company. And when you encounter any of these and a bunch more, then it's time to move on. Don't waste your career time or your expertise when you get into these situations. Next point. I, I think that's basically it. And I wanted to thank you all and turn it over to Sprague.
Thank you again, Clive. Appreciate that. I do want to say again to our audience, I know we got a few questions in already. We will be answering those at the end of Sprague's presentation here. And again, if you want to unmute and ask questions to either Sprague or Clive at the end, just let me know in the chat as well. With that being said, Sprague, do you want to share your screen?
So I started after college. I moved to California and worked at Varian, a big electronics company. And at the time, I had no idea what AIDC was, but it just so happened that my job involved microwave amplifiers at 2 to 4 gigahertz and really gave me an understanding of how RF operates, when you move your hands over it and things like that. So it was really a good background. I then went into graduate school, got a master's, and worked in superconducting linear accelerator lab and Josephson Junction labs, both of which involved RF. So that background was really pretty exciting, but also proved to be very useful in the coming years. So I joined the AIDC industry kind of serendipitously. I moved to Seattle because I loved being in the mountains and in the ocean. And later I found out, spent a lot of time in rivers, and Seattle has a lot of all that stuff. Intermec was a little company at that point, much bigger than Zebra was. It was a $10 million company, and they made barcode scanners and barcode printers. And this is a close-up of how we printed barcode at that time. That's a beryllium copper band, which is etched to form the bar and space patterns, in that case of code 39. And it would spin really rapidly. And there was a magnetic assembly with these little flags that had a coil in them. And when you put some current through the flag, it would go zipping out and smack the wheel as it was spinning. And in between there would the paper and the ribbon would be. And so it was a highly mechanical, very loud, very fixed type of printing, but it produced excellent quality. And as an example of the kind of problems I faced when I started there, they were having problems magnetizing these fixtures, and they would basically explode. So to solve the problem, they made a whole bunch of them and put this big plastic box around the magnetizing device, but it still wasn't making the magnet strong enough, so they got a really big magnetizer. And when I came in, I looked at the fundamental operation of how things actually worked and saw that their magnetizing box had a potting compound that was insulating the heat developed during this process. Plus, they soldered the pieces together in there, so so the things would blow up, and the uh, the 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 assemblers weren't very happy with this, and the company wasn't very happy with this. So they ended up buying a bigger magnetizer to get the things to work okay. And I went in and first thing I did was put a thermally conductive potting compound in there, and I replaced the soldered pieces with high conductivity oxygen-free copper that I etched using our little facility there in one single piece. And I made a prototype out of this. And the first time we tried it, there was no noise. It didn't blow up. We didn't even think it worked, but it was so the magnetization was so powerful, it collapsed the magnetization structure. Uh, Later, a problem I also had to solve. But we found out we could drastically reduce the voltage to magnetize the things. And then that single prototype lasted for the remaining 8 to 12 years of the product's life, never needing to be replaced. And it solved another problem because we could lower the voltage on the hammer flags, which eliminated some arcing problems we also had. So my physics background proved very useful in my early career, and it gave me a lot of opportunities in the company. On the side, I was also able to do some research in scanning and printing. And one of my early patents figured out a way to read blurry barcode symbols, which proved to be a very important contribution, both from a competitive standpoint as well as from an IP standpoint. So I ended up doing a lot of internal development, and I would recommend to anyone, it's always hard to fill out that disclosure. You know, you're forced to do lots of work fast, and there's never seems to be that time to get that patent into the company. And I would strongly recommend doing that, even if it's, you know, evenings and weekends. Get that disclosure written down and submitted, because not only will your company benefit from it, but being an inventor yourself opens a lot of opportunities in the future. So the barcode industry, which was something that Intermec was involved in, you know, I wasn't involved in. I was trying to fix printers and scanners, but there was a huge problem we had at Intermec, and since we made both printers and scanners, those Printronics labels that Clive was talking about were really pretty horrible, but the verifiers at the time said they were great, yet our scanners had a lot of problems reading them, and everyone would say your scanners are no good. And then we also had printing that I showed you, that print wheel on, which made spectacular, beautiful barcodes because they were impacted all at once. There was no building of the bars using big dots. So we had really good printers, but some of the verifiers said that our printed symbols were out of specification. So the problem I had to solve was to develop a very, very high resolution scanning device, which is over there on the left there, using a laser interferometer and a 16-bit A to D converter. And it generated a scan reflectance profile that I show in the front there, which ended up being still to this day the figure in the ISO print quality standard. So that got me involved in the standards world, developing this this method of measuring barcode that was based on what a scanner saw rather. And one of the problems with that development was that no matter how carefully and how noise-free and how repeatable I made this measurement device, the bars always were bigger than the spaces by quite a bit. And it turned out that had to do with light going into the substrate. But the bottom line was it convinced everyone that this was the correct way to measure barcode, which is what a scanner saw. So after DANCY standard was approved after 4 or 5 years of work, it was adopted first by the automotive industry, also the DoD, and was a huge improvement in scannability for industrial applications, which were most of our applications at Intermec. And I also worked with retail and electronics and healthcare to get this standard implemented so that everyone could get their labels made, measure them with a verifier that was the same across the industry, and have confidence that they'll scan in the real world. Along that time, I was nominated to chair the ISO committee, Work Group 1, which is responsible for all the barcode symbology and print quality standards over the years. And it unified the national standards, but it also provided an international forum in which to make good open system symbology standards and also print quality standards. So after the 1D standard was adopted as an ISO standard, we developed one for 2D symbols like data matrix and QR code, and also for direct part mark symbols, which is a very quickly growing application of barcode that has, has some symbols that are specular or shiny, in which the regular diffuse standard didn't work. And we also developed a print quality standard based on the same principles of, based it on what a scanner would see. And there's a close-up of a typical OCR font that you would see on a passport called OCRB. And we had to deal with little problems like security features and how to still measure the barcode. And that little photo down there on the right was the last ISO meeting before COVID, which was back when everyone actually showed up in person. And that was in the fall of 2019. And nowadays, about half of our members show up on, as I am here, on a Zoom or Teams meeting, and the other half show up in person. So some of my lessons learned, I went out and got a master's degree after actually leaving college and going into the working world. In hindsight, I think in many, many situations, there may have been, a little bump in salary, but it gave me a little bit of oomph when applying for jobs, when moving within the company, and when moving outside of the company. So I thought that for me worked really well. And I should point out, I am really based in technology work. Clive, also highly technical, but he went into the management track and actually, had a bunch of people working for him. I stayed as an independent technologist. And for me, where I lived was very important. I had a lot of fun stuff I did outside of work. And my company, because I had a lot of success inside the company, allowed me to take big chunks of time off to pursue my interest in the wilderness. Inside the company, I needed to find out how to make long-lasting contributions. The process control stuff, I was very successful in. Each time I was successful in something, I was allowed to do more work, finding problems and solving them. And my advice was I always tried to work myself out of a job. I found that if I could uh, solve a problem using root cause, fundamental information, I could pass that problem on to someone else and pursue the next problem. And from a technology standpoint, that really allowed me to do pretty much whatever I wanted. And in the standards world, we obviously had a lot of issues that we had to solve in that. And so the same skills from a technology standpoint were very useful. But also, there was a lot of the people skill stuff. When you're in a room with 20 or 30 people, half of whom, more than half of whom, don't have English as a first language. They come from many cultural different backgrounds. They have a lot of different corporate issues on their side internally, and trying to get a consensus often proved time consuming. But one great thing about leading a technology committee is all of our decisions were unanimous. If we had a problem where there was dissent or issues, we figured out tests that we could all run. Sometimes we would take barcode symbols and literally send them all around the world and have everyone measure them using their own equipment, scan them using their own devices so that they were all looking at the same thing. And in all cases, we came up with a solution that was 100% supported by everyone on the committee. That kind of work was very, very exciting to me. And I was just essentially very fortunate to have been in that situation. All right. I think that's it. And I will stop share and we'll see what kind of questions we have.
Yeah, thank you, Sprague, and obviously Clive, for not only your contributions to the industry, but your contributions here today. We do have some questions here that I got here in the chat. But if you do have a question you want to talk to Sprague and Clive directly, you can raise your hand and I will unmute you and let you speak. But we'll start with one because it piggybacks really well off what Sprague you were just talking about here just a second ago. And you gave a little bit of insight on this, but I'll also want Clive to speak on this too. They asked that you chaired ISO barcode committees for over 25 years. What personal skills mattered more than technical in achieving consensus at that level?
That's a really good question. I think an early lesson I had when my first leadership position was in the automotive industry on the AIAG committee, the barcode committee for implementing the print quality standard. And I was really a neophyte then, and I never led anything. And a couple of the old guys took me aside and said, it's really important to get everyone's opinion. And in any group, you have the talkers like me, and then you have the quiet guys that just sit there and really don't say something. And a skill that I developed whenever there was like some, maybe concern that we weren't all in agreement, I would just go around the room and ask everyone to give their opinion. And some people would say, yeah, I agree with John, but I think it should be a little of this. And you got everyone to say something, even the quiet people. And it very quickly, one, it brought everyone into the conversation. And secondly, it got ideas out there that maybe wouldn't have normally gotten out there. So if there's one thing I could say, it's really go out of your way to get everyone to participate, even the quiet folks in the room. And that was very useful in many, many situations.
Sprig, I completely agree with that, and I do the same thing. Another thing is about slides. Most of those people in the room can read English far better than they can understand and hear it. And so put everything you're going to say on the slides. You saw that in my presentation, so that people can read it and understand it through reading it, because maybe they can't hear it, or maybe there's an accent problem. Being a native New Yorker, I only speak English as a second language as well. So I do think you need to be very concerned about communication, and you need to understand how people interact in their own cultures, so that you know treat them in a way that they are always comfortable. So those are my additions.
Great. Thanks, Clive. And sticking with you, Clive, because you mentioned this earlier in your presentation, and that was, I think the term you used was cooperation, whatever, as a driver of industry growth. So, how should young professionals navigate collaboration with competitors while protecting their own career and company interests?
Well, yeah, one of the things you have to do is always keep in mind uh, the secrets and particular expertise of your company. But there are times when, as in the barcode standards groups, in which you have to understand that maybe you have an expertise or an experience which is different from other people and maybe will help solve a problem. And the other point is co-opetition from a marketing viewpoint. We were competitors with Intermec, but I had 5 different relationships with Intermec, depending upon the situations. And it was a wonderful experience because there were times I remember Roger Palmer, who was the VP of engineering there, and I sitting in a booth at a trade show trying to solve a problem in in together, because both of us applied our expertise, and also recognizing that we made barcode printers, but we didn't make barcode scanners. So it was really important to have a tight relationship with the scanner companies. In our case, it was with Symbol Technologies primarily, so that we developed products in relationship to each other to make sure that our barcodes could be scanned by their barcode scanners. And so we did a lot of informal um, testing together, uh, to make sure that everything worked as a system.
And Sprague, did you have any thoughts on that as well?
Oh no, Clive has hit the nail right on the head. We made both scanners and printers, so we couldn't point the finger to anyone else. But you know, the work in the industry, the huge collaboration to create a print quality standard that everyone could buy into, printer people that could use this standardized, series of devices called verifiers internally to make sure their stuff worked, and scanner people to do the same, and the user community, uh, when they're buying their barcodes, they could make sure that they were good and before they shipped them into the retail world so they wouldn't get fined by Kmart. The whole concept of making everything work together as a system from the printing and the scanning was the whole key to the early growth of the barcode world. It went from nothing, as Clive pointed out, to multi-billion-dollar business, within the period of 15 to 20 years. This is an unbelievable growth. And in my opinion, it was all based on everyone's focused attention on making the printers and the scanners work together as a system.
Great. So I think this question's interesting. It revolves around mentors, and basically what they're asking is, how do you know who is worth listening to? Clive, if you want to start.
I'm just trying to think about it. Sprague, you want to start?
Sure. Well, I had it easy. At Intermec, president, name was David Allais, was the inventor of Code 39 and basically started the industrial barcode industry,
Yes.
and was a tremendous mentor. And he was the guy that told me, he says, we have this problem with, printers and scanners. Everyone's pointing their fingers at us saying our stuff's no good. What do you do? And I said, well, to me, as a physics guy, you need to make a verifier essentially that's 10 times more accurate and 10 times more repeatable than any verifier on the market. And he just said, okay, go do it. And that led, to many exciting things. And then another mentor I have, as Clive already pointed out, was Roger Palmer, both of whom were at one point or another were my manager. And Roger was a total classic engineer extraordinaire. And he actually, with Rich Brobman from Symbol Technologies, started the AIM TSC. And they invented the first barcode standard. When they started, there was not a written document that said how to print code 39. And so they invented these uniform symbology descriptions, and that started things off on a great foot in the industry. So from a mentor standpoint, these were just the giants of the industry. And I would have to say, if you need to really get your ducks in a line before you talk to somebody, and they say something to you that is, productive and encouraging, you have found a great mentor. And for me, those two were a great start. And then I also have to say, once I got out in the industry and met people like Clive and Andy Longacre and Ted Williams, you just can't imagine better mentors than that. If you don't know Andy Longacre, he's the guy that invented Aztec code and many other great contributions to the industry, and Ted Williams, who invented Code 128 and and other great things in the industry. These kind of folks that I was able to interact with because of my involvement in the standards world were just phenomenal mentors. And I guess I was lucky. It wasn't hard for me to pick who to be great mentors.
Yeah, one of the crazy things is Sprague and I were both initially educated as physicists. Now, being a physicist is like being a Marine. Once you've done it, you're scarred for life, and your whole view is very much based upon that initial experience. I still look at everything from the viewpoint of a physicist, and I'm sure Sprague does too. So a lot of the people in the industry and a lot of the people that he mentioned were trained as physicists or mathematicians. And particularly when it got in the barcode standards area and we got to the 2D barcodes, whoa. I mean, that was so technical and so mathematical that the backgrounds that we'd had in hard science really kicked in. development of 2D barcodes is probably one of the most evolutionary things in the entire industry, because in the first 2D barcode, PDF 417, okay, they introduced a concept called error correction. That is, the barcode itself contained information such that if it was damaged, it has enough information in it to recover the data from the symbol, even if the symbol is damaged. And QR code is an outstanding example of a 2D error correcting barcode. And there are others as well. In fact, I think nearly all standards that are being application standards that are being developed today are being developed by using 2D barcodes because of space and because of the tremendous scanning accuracy you get with an error correcting barcode. So that's just a comment, but Sprague talked about Mentors beautifully.
So you both mentioned physics. So this question is, your early roles gave you deep hands-on exposure to RF, optics, and physics. So for young professionals who are more software focused today, how important is hands-on hardware experience?
Wow. Well, there's nothing like staying up until 3 a.m. hand loading data into a PDF, PDP-8 or a PDP-11, okay, because you have to use the front panel switches because you don't have an assembler. That kind of hands-on experience, well, unnecessary today, was very important in terms of my development. But I think that one of the things that in the software world that you have to be aware of is how these AI applications like Claude and other ones are going to help you develop code and are going to be able to read your code and understand it and find your errors. So I think the biggest thing I see going on in the software world is the uh, the impact of AI on software development. And that's so don't ignore it, guys. It could take your job, but you got to manage it rather than it managing you.
I would add to that from a hardware standpoint. Um, I was, I went to Varian right out of college, and in college, I did labs and stuff, and I worked in the low temperature area, and did my senior thesis and all that. But in at Varian, I was tuning amplifiers. I knew how to work an oscilloscope. I knew how to operate all kinds of test equipment. And when I went to graduate school, that experience actually landed me an RA rather than a TA.
Mhm.
And so I got the full ride and didn't even have to TA, and which immediately was placed in a lab because of my hands-on experience. And when I went to Intermech, we had, these. I explained how we had these big voltage machines in our uh, light pen one, which was the first barcode scanner, was just a single thing you moved over the barcode. There was wire bonding I had to do. There was encapsulation, and all of these things involved like mechanical equipment. And being comfortable dealing with mechanical equipment was always. And then I built this thing, which was I had to plug everything together and make it all work. And then I had to write the software to analyze those profiles. And so I think the hands-on being able to deal with you know electronic equipment as well as being able to code at least well enough to understand you know how coding works so that you can look at a program, or you can look at an outline of a program and make contributions to it. So I think the combination of a little mechanical hands-on with understanding how code works, whether you're doing that as a technologist or whether you're a manager, this is a very useful to really understand, what other people are doing by having some experience in both mechanical and software.
Yeah, in my PhD program at Case Institute of Technology, we had two things in it that was really important to me. One is I got to use a then very big computer, a Univac 1107, and I got to actually go in and find bugs in it and find where we had electronic failures or a transistor had failed. That was great. I mean, I felt totally comfortable. And my specialty at that point was computer design, a skill that was made totally obsolete by Intel when they introduced the 8080. But and so I moved on. But the other thing that was taught was development of computer languages. And that course turned out to be the most important course I took in my PhD program because we actually had to design and write compilers. And we had to design a language and write a compiler for it. And that was the skills that I needed to develop ZPL. And I understood the problem I was trying to solve, and I understood how to design a computer language. And that, boy, had a huge influence on my life.
And the whole barcode world, I would have to say, because that was a problem that we all faced, uh, and now it's just totally taken for granted that these computer languages are like ZPL are buried underneath label processing programs and things
Right.
that, it's all graphics today, but the basic language that Clive wrote is still the fundamental way that, those those printers are programmed.
Yep. Yeah, and I designed it because I wanted to create my own replacement market. Because since every time you bought a new printer, you had to reprogram it. Well, I thought this is silly. Why not design it so you can drop a new printer in without any code redevelopment? And that should be, think of it, reusable code and code structures that can accommodate evolution of the hardware underneath them are really important, which is why everybody programs in languages today and not in bits and bytes and with assemblers like we did.
Okay, we'll end here. Two more questions I'll ask, and then we'll close up things. And you know, post this webinar, I will send an email with Clive and Sprague's contact information if you have additional questions for them. I'll also have that at the end of the video if you're watching the recording version of this. So the next question is, why do standards organizations remain relevant as technologies like AI and automation evolve?
Well, in the barcode world, there's constantly new things. We never thought way back when that everyone in the freaking globe is going to have a barcode scanner in their back pocket. And, the standards that we developed then, are fully implemented now. And then there are newer barcodes coming out like Clive's Ultra Code that who knows in 20 years, that's what everyone's going to be scanning in the future. So the fact that everything today is based on the standards, and you can't just go to sleep and assume that's going to be the same forever because technology keeps evolving. And not just in barcode, but all across the world, there are standards being developed. And even in AI, standards are being developed. And uh, that's where the cutting edge occurs. And if you're lucky enough to be in a company that is involved in developing standards, then you are at the cutting edge. And if that's where you like being, then I would recommend taking full advantage of that, because we're going to, when you guys are our age, you're going to look back and, you know, be developing technologies that we never even imagined.
Yeah, we never thought that error correction technology would apply to barcodes. But Reed and Solomon, who were two mathematicians, developed it for Voyager. And it's obviously still in use on Voyager, but it's the whole key to Voyager because of all the noise that a very weak signal is exposed to from 5 billion miles or so. But that technology reemerged in barcodes, and it's been the whole key to developing 2D barcodes. RFID is another technology which exploded when people realized how to deal with the RF problem. And a lot of what we learned in developing RFID technology, particularly in antennas, came from the cell phone folks. So you've got to realize that good ideas come from lots of places. And speaking of that, writing patent disclosures is one of the things that I learned to do really well. To be able to take an idea and put it on paper, that's a skill that Sprague alluded to. You've got to learn how to do it or use a consultant to assist you in it. But patent lawyers are often not very good at picking people's brains. But when you're dealing with a technologist who can understand what the hell you really meant and can convert it to English, that's very important to getting that patent issued.
And so the last question I'll end with here is, what skills should young professionals focus on building now that will still matter 10 to 20 years from now?
Today, I'd put down RF technology as one of them because the whole world is RF. Everyone wants to take the easy route. They want to be a programmer because that's easy, or they want to do something, along that line. Digital technology is easy, programming is easy, designing antennas is really hard. But let me tell you, it's a skill that is going to continue to be needed regardless of AI and everything else. So, you know, don't just take the easy route, learn the hard stuff as well, because that's what's going to survive.
Now, I would add to that, learn the hard stuff that you're interested in.
Yeah.
If you're really psyched about some weird technology, even if it's not what your company is doing, go read about it. Get uh, well versed at the stuff that you think is the most interesting. And then I'll close with the other thing that I already alluded to is any way you could help improve your communication skills. You can take a course on how to communicate with people. You can do there are various speaking groups you can get up and get used to standing in front of an audience. And any way you could get involved with improving your communication skills, not only verbally, but definitely in the written word also, is going to serve you well for the rest of your life.
And don't be afraid to use ChatGTP, but don't, on the other hand, don't become dependent upon it and recognize you need to convert it to English when it's finished.
All right, great stuff, guys. Clive, Sprague, really appreciate your time and insights today. Appreciate the audience for their active participation and the great questions that they asked. And be on the lookout because the Young Professionals Group will be doing more town halls, more educational sessions like these moving forward. So you will be notified when those sessions are going to be happening. So thanks again, everyone, and enjoy the rest of your day.
Thanks all.
Thanks, Mike. Thanks, everyone.